Thank you.
My name is Kirk Carlson, and I grew up in Reardan, went to high school here, and then went away to school and got an engineering degree and went, basically went down to California and did my engineering thing down there, and then went to other places around the country, and then finally have come back because I kind of missed the area around here, but and whatnot. So that's kind of my nutshell of my life story. I don't like to call myself a historian because I'm not serious enough. A true historian has to keep track of all of the where the information came from, not just the information. I like just collect information and tell stories because it's I like the story part of this. But that's how I got into this stuff. And then uh, when I got back in the town, I started collecting the photographs that were in the library and trying to organize them better, trying to make them easier to find. And so in doing that, I put together a website, reardanhistory.net, that allows you to search for some of those photographs. Now, it's not a perfect website by any means because it really is a collection of research notes more than anything, but there are stories that can be made out of those things. It's like 10,000 pages now of stuff and photographs and from all over. A lot of it was the dams and in a lot of farming because the farming stuff is fascinating to me too. In the late 1870s, the first settlers started coming to around Reardan to settle. And the first settlers were cattlemen, because it was a lot easier to raise cows than it was row crops or wheat or whatever, because you didn't have to do so much work. You just brought your cows in, you let them graze, and then you would take them to market and stuff like that. So the land they were looking for had basic requirement is it needed good grass and it needed to have water. And so the land they sought out was the scab land, which, it's rocky and it's harsh, but in general, you could always find water in the scab land and you could usually find grass. So the first settlers were out east of Reardan towards Spokane, and they settled there. And then a few years later, some of the first wheat farmers started coming in. At first, it was pretty primitive. You would come in with a plow, you break the land, maybe an acre or so a year, and then you would plant by running around with a wagon, and then you broadcast seed off the back of it. So by broadcast seed, I'm just saying you're just spreading the wheat by hand. In 1888, the railroad came in, and once you had the railroad, uh, it came in again on the south side of the lake, and they put in a station. They had a watering a watering tank so they could replace the water in the steam engine, and put in a depot, and then all these buildings just sprang up. They were going to serve that train stop, and so there was they built a whole bunch of stuff: hotel, bar, uh, livery stable. In 1898 they built Washington Grain and Milling Company, and so that gave them a way of getting a vertical product from the wheat. So you didn't have to sell just the raw wheat; you could actually sell flour, and that flour ended up getting shipped around the world. When Washington Water Power decided to build that dam, it was the most remote dam that they had. I mean, they'd already built the one at Post Falls, and that was relatively remote. But I mean, it was along the Mullen Road, so it was relatively easy to get there. Going to Little Falls was a different story because there wasn't a real easy way of getting there. Washington Water Power, to do the transshipping, it wasn't just dropping it off a train and then putting it on a wagon. They actually took 3 city blocks of Reardan to build this transshipping point. So it was an area of the railroad siding at Reardan that wasn't used for grain. And so it was Washington Water Power's exclusive use of these 3 blocks. And they had a bunch of different things that they put into that area. So they had a bunkhouse, they had a warehouse for holding the cement. You don't want it to get wet, and so and they also don't want it sitting on a railroad car, sitting on a siding, because it just gets in the way. So they would unload the railroad cars, put it in the warehouse, and then ship it as they could down to the dam. Uh, they had a livery stable because they had all these horses that they had to feed. There was another building they had that had just horse feed in it. So I don't know if it was a hay barn or an oat barn or what it was, but they had two different barns for just the horses. They had their own blacksmith shop to keep the horses' hooves or mules, whatever they were using, and there was a, what do you call it, a steam donkey. I think it's a wood-fired steam engine, but then that steam engine is got a winch on it, and the winch is what they're using on the derrick because they didn't, like today you have a crane that would unload stuff or forklifts or whatnot, and they don't have any of that back in 1910. Everything was done with a derrick, which is basically a pole. At first you started with a pole, and then attached to the pole was this arm that would swing like this. So that would get you like that, and then it could swing around the pole to move the stuff off of a railroad car and swing it into either a storage place or into a wagon. But so, and all that activity was going on in this 3-block area. I mean, so I think it would have been a busy place, because you have a lot of wagons coming in, they're waiting, they're getting loaded, they're getting unloaded and moving on, so. And then you had to do the reverse down at Little Falls. You had to unload all that stuff. So they had to have another set of buildings down there that were basically doing the same thing that they were doing at Reardan. Eventually, they transported 18 million pounds of cement from Reardan to Little Falls, but they certainly didn't do it all at once. It was never stored in one place all at once, but you had, you bring in a carload of the stuff, you'd offload the car into the warehouse at Reardan, and then over time you would ship it down to Little Falls. So we set the scene, 17 miles, no trucks, no cars, no railroad. And so the only thing you had was horses and wagons and dirt roads. I mean, you had no gravel, no paved roads, anything like that. They were gravel roads. And then when you go through the canyon, it was this hard basalt. And there were various attempts to improve that road. I mean, Reardan had tried to improve it to go to a mine at one point. I don't remember the year that was, but they had improved it. And then when Little Falls wanted to be built, the county was making improvements to the road. And so Washington Water Power contributed money to the county to make sure that that road was improved. But I think that the main improvements was they'd go in with dynamite and blow up the big rocks so that they could at least get a wagon through this passage. I can't imagine that being more than one wagon width wide, but I also don't know how you manage the traffic going up and down that road because you had so many wagons that had to make that trip. I mean, I don't think that you could do one way in the morning and one the other way in the afternoon. Logistically, I don't think that would work, but maybe that's what they did. But you had to do something because a lot of that thing was going to be a one-way road, and there's no way to meet anybody, or very difficult. And you can't back up a horse, and you can't back up a horse uphill, and so it's not an easy place to build a dam. So you got 18 million pounds that they claim got transported down to the dam, and I'm assuming that that's the total number of pounds. I'm also going to assume that a wagon would haul about 100 bushels of wheat. So 100 bushels of wheat, 60 pounds a bushel, that comes out to 6,000 pounds, about 3 tons per load. And so, the wagons were not super well built. I mean, they basically were two 4x6s and then a little bit of planking in between them. And that was it. They were made out of wood. I think they had some metal parts in the axle so that they would wear a little better, but they're a primitive device. I mean, when you really think about it, they were mainly made by a carpenter, not made by a mechanic. But anyway, so you take that 6,000 pounds and 18 million. So that tells you there's 3,000 loads, but that's not counting any of the steel. So they had the generators and turbines, they say weigh 750 ton. And so if you took a steel wagon and they could handle 12,000 pounds, 6 tons, it still would be 125 loads for each one of those turbines and generator sets. So, I mean, overall, that would be another 500 loads of material just for the generators and turbines, and then you'd have another loads of stuff going down for the towers, the steel that goes into the wiring, the transformers, all this other stuff. So, I mean, there's a lot of loads, a lot of loads. And so you're talking about a lot of traffic here for those 3 years. I mean, it would have been, I don't know if it'd be busy as US 2 is today, but it would have been pretty busy. I mean, easily you're going to have a couple loads an hour leaving town and going down there, and that's why, you had 3 blocks in Reardan to load this stuff out. So that's a lot of place to load stuff out. And then don't know exactly how they handled the congestion down at Little Falls, because when you look at the pictures of the construction site, it didn't look like it was terribly well organized. And I don't know how they did it. I mean, logistically, it would be fun to see Washington Water Power's records if they kept them about how they did the loads to get them down there. Because there's a lot of loads, a lot of people, a lot of horses, just moving this stuff is, it wasn't as easy to move a wagon with horses as it was to move a truck. It seemed like it was easier just to go from Reardan and just make a go for it. I mean, it was a fairly simple straight road, and it was downhill all the way. Sometimes too steep, but it was downhill all the way. And I think it was a relatively easy choice for them to say Reardan.
My name is Nate, and I am the on-shift operator here at Little Falls Dam, one of 7 for the Lower Spokane. We run a 12-hour shift here, and I'd like to show you what we've got here. They built the dams concurrently. The spillway dam and the intake dam were built at the same time. The powerhouse was built at the same time the intake dam was built. It was built by from what I understand, mostly local. And they brought in many people. They built camps that were close to the facility. They actually built a village for some of the more permanent people, your operators, your maintenance people, supervisory staff, some of your engineering. They actually had a village out here. It was a town. They had a school teacher. There's foundations that are still there. Actually, some of those houses, the operator houses, were moved up to Reardan from the railroad, and then to be able to bring the supplies from there to here. And teams of wagons, that was part of it. They actually had a steam-driven tractor that would bring the bigger stuff down, like your turbine shaft and rotors or runners. The actual generator rotor, it would be brought down that way. The forebay, we'll start there. That's where the water collects that gives us the amount of height for the power output and potential energy for the turbine units. The spillway is where any excess water gets diverted that's not going through our generators. And penstocks are how the water gets from the forebay to our turbines. So here we have is a 3D printed model of each representation of each one of our units. Our penstocks come in the top. These are our scroll cases, draft chest, and then that exits out the water outside into the tail race. This is our generator. Our stator is the stationary portion, and our rotor is also our field that rotates past the stator to make the electricity. Bearings, and now we will go through that portion. So as the water comes in through our penstock and our scroll cases, it passes through our wicket gates, which are our nozzles. So that increases our velocity of the water going to our turbine runners. And as these turbine runners receive water, they spin the turbine, which spins our rotor, our magnetic field, and makes our power. The generators have been refurbished. Up until about 2012, we were on the original generators, and they had Alstom replace those units. The scroll cases are all original. The turbine runners, the actual turbines inside the turbines, are all new. We've gone through several different upgrades and changes for controls as far as the governor goes. Today we're making 10 megawatts each turbine. The generators are capable of making 12 MVA or megavolt amps. This helps us with our grid support for voltage. The original output of these units was right around 9 megawatts, and that was limited mostly due to amperage on the generators themselves. We maintain this facility well and plan on doing it for foreseeable future. I think water power was a strong builder for the region, and it still is a strong power source for the region. It gives us a nice, clean, renewable, and steady supply of power.